down because 2 is already prime. So I'm just going to write it down here. I'm just going to bring it down here, right? Is this the prime factorization of 18? What's 2 times 3?
6.
6 times 3?
18.
So is that what I get?
Yeah.
That's the prime factorization. So let's do the same thing for 24. Claire, you can do it now.
Okay.
All right.
Make that one. And then you 12. Oh yeah, 12 times 2.
Okay.
And then you bring the 2 down because it's a prime. And then you take 6 times 2 because that equals 12. And then 2 is a prime number, so keep that there. And then 6 take 3 times 2 because it's not a prime number. And then 3 and 2 are prime numbers.
So I have to bring those down, right? All right, now I got 2 prime factorizations on here. You did a factor tree. You got the prime factorization of these 2 numbers. What's my next step? Someone I haven't heard from yet? Sarah.
You see which ones are in common.
Okay, which ones are in common? I like to line mine up because, like I said, I don't remember things very well. I'm very visual and I have to draw it out very nice and neat. So, well, I shouldn't say neat. Math gets messy. But I like to draw it out here. So I'm going to do 2 times 2 times 3 times 2. Does it matter what order I put these in?
No.
Is 3 times 2 times 2 times 2 the same as 2 times 2 times 3 times 2?
Yeah.
Yeah, so it doesn't matter with multiplication what order I put it in. So I'm going to put it in the order that makes sense for me so that I can line them up nice and neatly. That's the way I do it. Because I get messy and I want to see it all perfect. So that's the way I do it. So now what do I do with those 2 bubbles that I just circled, Patrick?
Well, you figure out which one's larger, so 2 is not the greatest common factor, 3 is.
No. Is his thinking right there?
That's right.
Sam?
Wait.
I circled 2 numbers that match.
Oh. So.
Patrick, what do you got?
Is 9 the greatest common?
No.
There's not.
Abby?
Don't you times the 2 and 3?
Who agrees?
Yeah.
Okay.
Oh yeah.
Oh, yeah. So we remember that, and Jaren's like, yep, that's what you do. So I multiply the 2 and the 3 together, don't I? When I get the matches, I just use one number from each. What's 3 times 2, class?
6.
So my greatest common factor of 18 and 24 is?
6.
Is that exactly what you were going to tell me?
No, I was doing it until you had to circle one of them.
Well, you just circle them in each row. You don't line them up like I do, which is perfectly fine. Yeah. Make sure you get the right answer. That's perfectly fine. Now, so we got greatest common factor. You learned about least common multiple. Tell me what a multiple is. I learned what a factor is from you guys, so what's a multiple? Someone new. New hands, new hands, new hands. Sharon, Holden, Alex, haven't heard from you. Courtney, haven't heard from you. Haven't heard from you.
You haven't heard from Alexis?
Yeah, Alexis gave me an answer. It's a multiple.
I can't explain it.
Claire, help them out. You can't explain it? Okay, then you tell me if Claire's right.
Okay.
Since you can't explain it, if Claire does explain it well, then you should be able to tell me if she's right. Would you agree? Okay, so you tell me if she's right.
Okay, so a least common multiple is, oh wait, what is a multiple?
Yeah.
Okay, so like, for example, 2. So you like 2, then it goes to 4, and then 6, and then 8, and 10, 12, 14, and so on by 2s. And so then you take, and then you can take another number.
Well, let's just ask Jaren if you're right on multiples. Is she right on multiples? Yeah. So a multiple, Sam, go ahead.
Well, it's like 2. Okay, 2 times a number.
Yeah, 2 times 1, 2 times 2, 2 times 3, 2 times 4, right? Those are all multiples of
2. And there's like multiples
and
of 4.
these are factors of 24. So when you did 24 at the very beginning of class, you told me it was 1 and 24, 2 and 12. You can use 6 and 4, and you can use
3 and 8.
Yeah, 8 and 3. Those are all factors of 24. And these are all multiples of 24. Right? So I'm taking a big number, and I want to see all the numbers that go in it for a factor. And for multiples, I'm taking a little number, and I'm multiplying it. Multiple, I'm multiplying. The easy way to remember? But you did good, because the first class messed up on multiples, didn't they? Yeah. All right, so now, we know what a multiple is. What's the least common multiple? What is a least common multiple? Oops, I erased my thing. Sarah.
It's the multiple that isn't the highest number.
Okay, so how would I figure out? You want to use 18 and 24 again?
Yeah.
Okay, so we had 12 and 2, 6 and 2, 3 and 2. I should have left this up here. 3 and 3. Is that right?
Yep.
Okay. I'm going to line them up again. Is that okay with you?
Yeah.
Because I like to see them all together. 3, 3, and 2. You know what that dot means, don't you?
Yes.
Times. Multiply. Okay. So then we have 3, and we have 3 more 2s, right?
Yeah.
Here's one, here's one, here's one, and here's one. I like to circle them because I don't want to miss any. Now, what do I do? Got 2 people that remember, 4 people, 5, 6, 7, 8. Hey, Jaron, what do I do?
You times them all.
I times them all. So I take 3 times 3, times 2,
Yep.
times 3, times 2, times 2, times 2.
No. Just 3 times 3 times 2, and then after that you take 3 times 2 times 2. Times 6.
Who agrees?
Wait, what?
I said who agrees?
No.
He said you multiply all of these and then you multiply all of these. But you're on the right track. If I multiply 3 times 3 times 2, Jaron, I'm going to get what? What's 3 times 3? 9. And then 9 times 2 is?
18.
So this is what we do with that to get this number, right? That's the prime factorization. But I want the least common multiple of both these numbers. So I'm going to do something to both of these first. What am I going to do to those? Peyton?
Can I show you?
Sure, I'd love for you to show me. What do I do?
So these two are the same, and these two are the same. So you only have to multiply those by 4.
Real loud, because I don't think Patrick can hear you back there.
So, and then put them in order. And then I multiply all those.
Okay, so you used 1, 2, 3, 4 twos. 1, 2, 3, 4. But you only used 1, 2, 3s. How come? Did you have an extra 2? Yeah. Alright, so now we have a new multiplication problem. So she's telling me these match, right? So they're partners. And these match, so they are partners. So they go everywhere together as 1. So I'm just going to use them one time. So I'm only going to use the 2 ones. Got that? Okay, now this is how I think about it, because I keep telling you that I like to see it, right? So I know these are partners. I'm going to keep them together. They're always going to go as 1. But what about these guys? Are we going to use them? Yeah. And greatest common factor, did we use them? No, because we want the greatest ones. The only ones that match. They're the greatest, okay? But here, in least common multiple, we're going to use these losers. So they don't have a partner. And in gym class, if you don't have a partner, you might look like a loser because you don't have anybody to play with. But does Mr. Jones say, too bad, you're out of here? No. You get to play, right? So that's how I remember least common multiple. I make sure I remember to use those losers that don't have any partners. So that's how I remember the difference between greatest common factor and least common multiple. Does that seem silly or is that smart?
Smart.
So you might want to try that. So now I have a 2. I have a 2. Remember this pair is, they're partners, so they go as 1. I have a 3. I have another 2, and I have another 3. So was Peyton right?
Yep.
Yeah. So let's do this multiplication. What's 2 times 2?
4.
What's 4 times 2?
8.
What's 8 times 3?
24.
And what's 24 times 3?
72.
Ooh, nice mental math. Is it okay if I have to do that on my paper?
Yes.
Yeah. So what's the least common multiple of 18 and 24?
72.
72. Is that what you just learned yesterday?
What? Wait.
Did you just learn that yesterday? That line, what operation does
Half
that
of a
equal? Chloe, what are you working on? Huh? Nothing? What's that line? What operation does that line mean, Eldon? When I say operation, what does that mean?
A divider?
Yeah, operation is either divide, multiply, add, or subtract. So here, that line always, always, always means divide. So this is 1 divided by 2. So if I have 1 pizza, and I divide it into 2 pieces, how much would I get? If I had 1 pizza, I have 1 pizza, and I'm going to divide it into 2 pieces. How many pieces do I get? 2 out of
1.
1. Right? So this is 1 piece out of 2. 2 pieces together make 1. Now somebody said you get 4 pieces. Can I get 4 pieces?
That'd be 2 4s.
Is this different than this?
No.
Ooh, I have yes and I have no.
No,
Defend your answer.
no, because it's just on different sides.
Yes, because the
No,
Yes,
it
yes.
is.
One has 4,
No,
one has
because it's a
2.
half. 2 fourths and 1/2 equal.
Oh, I get it. Oh, I see it. Yeah, that one's sliced into 4 pieces, and that one's sliced.
Like 4 eighths, 2 halves.
Okay, so this is sliced into 4 pieces, Eldon said. This is sliced into how many? Colby? 2. But Sam's saying they're the same.
They are. Well, they kind of
Okay,
are.
wait a minute. You just told me this was 4 and this was 2. How can they be the same?
Because they're divided into that much. So
Patrick?
In simplest form, 4 eighths is 1/2.
4 eighths